Well, hi and welcome to my shop. We're going to continue with this radio I've been working on. This is and I apologize once again, I've still got a cold. So if I sound a little nasally and cough a little bit, and watch out, I'm afraid I may even sniffle a little bit, so sorry about that. But I'm not crying about this radio. That's not what's going on. This is quite challenging, so challenges are good, aren't they? And I gotta make a comment before I go any further. If you've been watching my videos, you've probably heard me say I live outside of the city of Toronto. And for those of you who are elsewhere in the world, you're probably hearing little bits and pieces about the mayor of Toronto. I'm not going to go into it because I don't want to be political on my TV channel, but let me just say, if you are here, this is all that's going on now, 24/7. What is going on with the crazy mayor in Toronto? And it's unbelievable. Unbelievable. So, actually it takes a little bit of effort for me to turn off the regular radio and sit here and talk to you, because just like everybody, I am dying to hear what's going to happen next on this wild, wild story. So if you don't know what I'm talking about, it would only take you a few clicks on the internet. The mayor's name is Rob Ford, and the mayor of Toronto, and just have a read and feel some sympathy for all of us up here. You know, Toronto's a big city, 2.5 million people, and boy, the mayor does not, I don't want to say represent, that's not quite the right word, but as you can imagine, he's an extremely unusual character. He's not like typical Toronto people and typical Toronto politicians either. This is a really extraordinary situation. Okay. Now, let's get focused on this radio. I think what I'm going to try to do now, having studied the schematic and I really get caught up in the wafer switches and trying to understand the wafer switches. Basically, I can't. It's too much effort. I'll probably get it wrong anyway, so I'm going to take a different approach here. We're going to do a little poking around and try to see, since the radio appears to be essentially dead on the AM band, where that deadness starts up. So I'm going to try to work a little further in the radio, work my way back to the front end, and just see where I can no longer inject the signal. And the signal is just going to be the screwdriver here making noise. That should be enough. So the radio right now, you can hear it. It's receiving. It's not on the AM band, because on the AM band it's totally silent. Right now the switches are set so that this push button set is engaged. Look, here's the push button set. I don't even have it connected to the radio right now. And I've installed this shorting lead. It's required because the audio from the output of the radio stage going to the audio stage passes through that set of push buttons. So this wire is imitating the audio control part of the push button set. So let's see where we can make some noise happen here. Okay, so just as you would expect. Yeah, we're going to flip to the AM band. It's just a little, I should put the knob on it, shouldn't I? Put a knob on it. Now there's the silent AM band. We'll try the same thing here. Okay, so I'm tapping on this coil down here. Isn't that strange? I really thought I would hear nothing down here. So we're kind of, you know where we're headed? We're heading right back to this loop antenna. I wonder if I wired it wrong. It's actually basically shorting. Can you do that? Can you? I'm sure I followed the wiring just as it was. I was very careful about that. There's no chance it was wrong to start with because it was factory. So, you know, even if, say that capacitor is shorted, I don't think the radio would be completely silent. What if I touch that? Let's turn this up. Now I'm touching a part here. You might not be able to see it. Back on the beamoscope antenna, and this is where you put a long wire extension. And I believe that's right here. And you can see it's more or less connected to the antenna terminal on the back. Where's the antenna terminal? Hey, how do you like that? Huh. Holy smokes. Could it be the beamoscope? Let me unplug it here. I'm pretty sure without the beamoscope plugged in, there's no AM antenna at all on the radio. Well, let me unplug it. Even though I've never ever made a mistake before in my life, there's always a chance I've made my first mistake here. Come on. Okay, out she comes. Okay, now it's unplugged. No, now there's no beamoscope plugged in at all. Oh, I should have had this turned up a little higher. Listen. Oh! Mr. Beamoscope, maybe you're the problem. Okay, so now, with that unplugged, well, maybe I'm picking up something. Let's check it out. Doesn't seem like it. Hang on a second here. Didn't I discover the oscillator wasn't oscillating? What am I doing? I'm off in the wrong direction here. Or am I? Yes, the crazy fleeting thoughts that go through your mind while you're doing this stuff. Especially since, frankly, I am a little sick and I didn't get a lot of sleep last night, so my brain might be a little slower than its normal slowness. Okay. Wow, you know, it seemed like a great idea. I'd poke around and find something, and I just feel lost on this thing. So, I was just touching either side of this capacitor here. If I go, let's touch the high side of this one, if I can. Well, that's it. Okay, so that point I'm touching is right here. So why so quiet otherwise? Oh boy. So it's as if I inject the signal. Hey, let me put my finger on there and tune it. Okay, what I'm hearing is as I tune from one extreme end of the band to the other, the noise and the sound isn't really changing in quality, it's just getting a little louder. I don't know what to make of that. Something's wrong. I think I can be pretty sure of that. Okay, other side, let's see, both sides of this coil. Okay, so this is the high side. Let's call it the high side on the page here. The other side. I don't know what I'm doing. I'm still really quite confused about this because this coil has 1, 2, 3, 4 terminals on it. The coil on the schematic has 1, 2, 3 leads to it. Both ends and a center tap. That's 3. Now, why would there be a 4th terminal on here? The center tap is connected here. I gotta go over this again. Here. So that's a center tap. So, just based on my touching here, I'd say, from what I can see, center tap, low end, high end. This would be the low end of the coil. Down here. You still hear stuff. So that's telling me I think that means that this coil is continuous, and it's a pretty heavy wire. There's not too much chance of this actually being broken. So I'm checking to see if there's basically an open circuit in here. I don't think so. I mean, I've checked it with an ohm meter and everything, and it just keeps indicating there's no problem with this coil. Oops, sorry about that. I wonder if we can find this guy. C40. C40. 680. C40, one end of it is connected to the 5600. So this is probably it right here. And this guy's going down. He's connecting to a terminal. There's another similar capacitor on it. So the other side's connecting to, no, it goes straight to the switch. There's no sign of a capacitor off of there. What is going on? Okay, let's look again. So this is the same as that, is it? Oh, it isn't the same. Oh, wait a minute. How can that be? Let me give you a closer look at what I'm doing here, because this doesn't not making a lot of sense here to me. I'm going to tip my camera up just a little bit here. There we go. Okay. So what I'm looking at is right here in the wafer switch. And I see this terminal and this one. And I would swear that those are supposed to be connected together through the terminal via the rivet. But it really doesn't seem to be the case, does it? let's give it the old ohm meter here. I don't like doing this with a radio operating. Let's first we'll check for a little voltage there. If we see volt. Well, you know, that's enough evidence. Those are not connected together. Holy smokes. How long have I been doing this? Apparently not long enough. Now I can see a little extra structure in there under this terminal. I can't believe that these aren't connected. I'm trying to touch the rivet in behind here now. You can barely see it. Okay, that's the rivet. How do you like that? The rivet is holding this. This guy somehow is not making contact there. Is that correct? Okay, so let's look on the schematic and see. Schematic shows there's the 2400 here. There's the 2400. There's one side connected towards the coil and the other side heading to the switch. And it doesn't show any other capacitors, does it? Well, I guess I'm just learning a lesson about these switches then. Kind of surprising to me. It's surprising. Okay. So that being the case, what's that telling us? I don't know why I'm even up on that capacitor anyway. It's actually in line with the B band, not the A band. So there is a connection through this coil. Now all these are all connected together in a really weird pattern like that. So pretty much you touch anything in here, it's going to come through to some degree. So I think I'm probably going from touching here to touching here. It's probably what's happening. I'm getting a little bit of sound and a lot more sound here. And none of this is helping me much. Okay, so the 56 is this guy here, I think. Looks like 5.6A. Wow. Now let's make sure where we are here. Are we on the right band? I'm not even sure anymore. Okay, so that's the A band. The radio's turned up quite loud. We get quite a boost off of here. Huh. So, I mean, I guess the simple thing is just replace these guys and get rid of them because, you know, they may not be shorting, but they may have no capacity left. What's going on in my head is these are really small capacitors anyway, so I mean, how much smaller can they get? I guess you could have a broken lead or something and make them just go to zero, but not too likely. But there's a dramatic difference across this capacitor. Which ends which? Let's see. Where do we get almost certainly this is where we get the loud signal, and on this side almost certainly this is where we don't. But let's see if we can prove that. So one side goes to this variable somehow. Oh my gosh, this guy? How's he gonna do that? capacitors disappear up in here. Oh, there's another capacitor right there. In the dark. In what's dark for me, anyway. Gee, I'm in that situation where I just don't know what to do. You know what I might do is get rid of all these. This guy, one in there, one here, one there, just get rid of them. They're all cracked. And see if that just doesn't make my problems go away. Now I also know a couple of these capacitors are probably the wrong size, based on kind input from one viewer in particular. But I'm going to have to watch back the video and figure out just which one it is. It's going to be a .047. The suggestion is it should be 10 times smaller, which is a big difference. Would that cause these problems? I don't think so, because these problems were here when I started on the radio. The other bands are working, unless I put in the capacitor only for the AM band, and I did not do that, because it has to be these guys. Unless I'm overlooking something, unless I fool in this area, I'm not doing anything only to the AM band. So yes, and I think I can hear my favorite viewer, Mr. Bobby, saying, just do the capacitors, just do those capacitors. Yeah, you know, it wouldn't be as much fun if you just put the radio, change all the capacitors, turn it on, and it works. You'd never know what it was. And as I've explained before, that's never my approach, to do wholesale part changes without strong evidence that it's necessary. So I think that's what we're going to do. So I'm gonna set up for that, changing some capacitors. Okay, now, first couple things. First of all, Mr. Medium Wave Station 64, first, thank you very much for watching my videos and pointing out the apparent error I made up in this part of the radio here, with this capacitor here, this green one. Because this is supposed to be, it's originally a .005, and I've put into it a .0047, which is just fine. But while I was doing that, I stopped saying .005 and started saying .05. So you picked up on that, Medium Wave Station 64. Thanks for watching so carefully. And I'll be checking in with my doctor later today to see how far the Alzheimer's has progressed and whether I can continue doing this work. And I think, you know, I moonlight as a brain surgeon. I think I'm going to have to stop that too, because I'm saying one thing and I'm doing another. Holy smokes. I tell you, life as a human being. That's one thing. Now, that's aside. Number two, I got to talk to you guys about what's going on around me here with the city politics in Toronto next door. Now, just to be clear, I don't live in Toronto. I live right outside of Toronto in an abutting city called Pickering. So, you know, it's not my mayor. I don't vote for him. But Toronto is the largest city in Canada. It's the 4th largest city in North America. And it's very proud of the way it operates. And this crazy, crazy stuff is going on with the mayor, and every day it gets crazier, and you just think it can't get any crazier than it already is. That basically the entire council has asked him to leave, and he's just staying there, and I don't know how much support he can have anymore with the general population. It can't be much. There's a never-ending demonstration down at City Hall now asking him to get out. And just a few minutes ago, what did I hear on the radio while I was in my office checking out this capacitor? He is going to sue his own staffers that he hired for talking to the police. And this is just unbelievable. Unbelievable. Oh, I feel like I can't work on the radio today. I just got to go listen to the news minute by minute. It's beyond belief. Beyond belief. Okay, so I invite you all to check up on the news here if you want to know what it is I'm ranting about. This outrageous situation, which is not reflective of Canada, Canadian politics, Canadian politicians. Yes, politicians are politicians around the world. But, you know, one of the great things about Canada is the level of corruption is so low, and people are so dutiful in their jobs, even politicians, especially at the municipal level, tend to be very dutiful and are trying their best all the time to do the right thing, even if you don't agree with what it is they're doing. They're not out there doing crazy stuff. Well, all except for this one guy. So, okay, enough pontification. Let's work on some capacitors. Yeah, that should be exciting. I'm trying to get my mind off the insanity. Just one last thing. This is a little hard on me because I used to work for the electric power company in Toronto. And like so many others, I felt I was working on taking care of the city. So even though I don't live there, I put a lot of my life there. I did live there. I did live in Toronto at that time. Man, one-man wrecking show. Just wrecking things. And you know what? Okay, I'm going to talk a little bit longer. Here's one of the things I've learned in my life. You know, society is full of institutions. You can name them, all kinds of them. Educational institution, your police, the medical system, and on, and all the large corporations, all the just everything that's institutional. And what I've learned is when you disturb a large institution, maybe something where there's 400 or 500 people, or maybe even thousands working together, when you disturb one of these institutions, it doesn't take much to make them fall right apart and become, yeah, and then, you know, they can't put themselves back together easily. And this is why I would be so concerned about a guy like the current mayor. Although at this point his wings are pretty much clipped. He can storm around like he's doing, threatening lawsuits and stuff. He can't do much damage at this point. Actually, in our political system, mayors in Canada are not very strong. They have the same voting power as a regular city councillor. Now, Toronto's a little bit different. It does have some executive powers associated with the mayor. But again, the council itself really is the more powerful body. So, luckily, this guy couldn't do too much damage on his own. Oh. Okay, I'm sorry I'm venting to all of you. Many of you are far away and in other countries, and Toronto doesn't mean a thing to you, and my feelings about it also don't mean a thing to you, but I need to vent once in a while. Let's see if I can get focused back on this thing now. Whew. Okay. So, let's get rid of this thing. 2400. Here we go. What is the actual size of that capacitor? Well, it's a little big. You know, I did do a little research on the internet. Can't say I found something that pointed to this kind of numbering exactly. Look at the size of it. It's probably a 0.02. So, I'm not sure though. Yeah, I don't have the equipment to measure it too. That's one thing I'm lacking in my shop. I mean, I got my multimeter, but it doesn't work. You know, you can't even test something with this size. It's meant for the little modern ones, like the green ones I've been installing. Ah! What should we do about that? 2400. Oh man. Well, what's it say on here? 2400 micro. Now, I happen to have a chart, and thank you. I think a couple of guys sent me charts, trying to help me out. I got charts. I just have to be smart enough to look at them. So I'm going to take a look at the chart, identify the size, get the replacement out. Okay, so after checking the chart, 2400 is almost certainly 0.002. That's what I'm going to stick in there. 0.002. Okay, I'll put this guy in there. 222K 0.002. So he's going to go right there. Let's nip out the old guy. Boy, I tell you, I really gotta stay away from the radio today, or I won't get anything done. Yeah. Now, you know what? I went and got my flu shot a couple or 3 weeks ago. And you know, I have a lot of faith in science and technology and the like, and so we're told quite clearly the flu shot cannot make you sick. But I know there's lots of anecdotal stories of people who, I get the flu shot, I always get sick. And here I am in position to make that claim. I had the flu shot about 2 weeks have gone by, and here I am with a cold. It's the first time I've had a cold in a few years. And my mother, who is in her 80s, also got the flu shot. And guess what? She got a cold too. Now, I could easily take this anecdotal information and join the others who say, oh, I get a flu shot, I get sick. Because of the power of the, let's call it the anecdotal experience, which frankly I encounter so many times with people. It drives me batty because they, you know, most people do not think scientifically, and most people do not accept that their own anecdotal experience must be ignored. Most people can't accept that. That's what I do in life. So I will not claim that my cold is because of the flu shot. Coincidence is a satisfactory answer for me. Doesn't make me feel any better though. Okay, so that's one done. Now we'll try another one that I don't know what the heck it means here. Let's there's one down here too. So, well, let's go after the easier one here. Maybe as I do this, I'll get a little more comfortable with the way they're numbered. And this guy's got a crack through him anyway, so he's got to come out. Let's just nip him out of there. Crack right through it, and it's quite clear it's 5.6A. Now I think I know where this one is on here. Where'd he go? I think it's that one right there, 5600 microfarad. You know, it looks roughly. Hey, you know what? How can that be? This big one we just took out is 2400. The smaller one is 5600, twice as big. Oh, man. I looked on the internet to try to see what 5.6A means on a capacitor. I couldn't find anywhere that explains it. There it is there. 5.6A. Sorry, I'm holding it upside down for you. to. Let me turn it around. I'll look at it upside down. How about that? I'm pretty sure that's the guy we just cut out of there. Maybe it's not. Maybe this one down here is that. Come on, how can a 2400 be so big and a 56 be so small? Why would it be like that? Well, regardless, we'll just have to go with what we've got here. So it's not really making a lot of sense. Let's just make sure I know where this came from. That might help. So one side's on this coil. 1, 2, 3. It's got 4 windings on it. It's a busy coil. And I'm pretty sure it's this part of no. Well, it could be up in here. Yeah, maybe that 5600 is actually this thing down here, and I've actually jumped all the way up into this part of the radio here by pulling this guy out. Am I lost? Yes, a little bit. Oh, here's one I replaced right to the same spot, so I've been here. Oh, it goes down to this pin on this pin number 8. Oh, that's good. Pin number 8 on the RF tube. I should be able to track back quite nicely then. Pin number 8 coming back. There's the one I changed. Oh my god, I don't see any capacitor other than that. I'm going to change the camera here so you're seeing it the same way I'm seeing it. Voila. I'll be hearing lots of funny sounds right now being transmitted through the my lamp, because I've got the camera hanging from the spring lamp. So okay, let's get down to it. Where am I and what am I doing? Right, off of this pin, pin number 8, going back, oh, okay, and that comes down to, oh, look at that, 5.6, there it is, 5.6, micro, oh, excuse me. You know what, it looks like the size of these things doesn't have much to do with their value, the physical size of them. So who knows what they were doing inside these. 5.6 micro. That's a really teeny tiny thing, isn't it? Because this was 2400 micro. This is 5.6 micro. So this is a tiny capacitor. It's like a 0.000000005. So you know what, I'm going to go consult my chart, try not to listen to the radio and hear more crazy news, and then I'll be right back. Okay, well, according to what I'm figuring out here, the 5.6 micro is the same as a 0.005 nano. I don't think I have any such thing. My meter is set to 2 nanofarads. So you see 0.005 is what I'm looking for. 5.6 really. And this is about the smallest I've got. 0.03. I don't know what to do there. That's a factor of 6 out. We put too big a capacitor in here. You know, it's in amongst all these coils, and I mean, it could easily be some kind of resonance thing going on somehow in there. That says N750. I don't know how to read that. How much I want to bet it's Nano 7050 or something in the. Well, you know what? I'm going to stick this in. I don't know what else to do. I'll stick this in the radio, and certainly not the best way to do this. It's my own radio, so I guess I'm entitled to mess it up a bit. Does this capacitor affect all the bands, or just one in particular? Yeah, it looks like it's in a plate circuit of the RF amplifier tube, so I would say it will affect every band. I'm not going to be happy. Not happy about doing this. Let's solder it in like that. I'll stick them in. Oh. Calmed down now from my political tirade earlier. In case you don't, I mean, you you could be anywhere in the world watching this video, and you may never even heard of the city of Toronto. It's a wonderful city. It's a real going concern. Lots of construction development, lots of stuff going on. I guess this is where you hope the institutional aspect of the organization will hold it together through something wild and crazy like what's happening. Oh, my camera slid. Get rid of the excess wire there. Should we test the radio? I don't think so. I'll be a little more cautious about replacing those little capacitors, though. Just because I don't know if I have any suitable replacement beyond the little one I just used. Okay, and you know, I really thought I was down. I thought I was down in this area. So let's find this bigger 5600, which should be twice the size of the 2400. There'd be a big one in there. And If it is, it's hidden from my view. Oh, it could be one of these. Yeah, it could be one of these, what I think are mica capacitors, which are well known to be highly reliable. That would explain the smallness. So it's connected. Should be connected here. Oh, maybe I already did it. It's supposed to go. I don't know. Okay, let's reverse our approach again and pick on the capacitor. Oh, look, there's another one down in there. Yikes. I really don't want to be replacing these unnecessarily. I mean, this one was cracked, the one we replaced here. The one I just replaced now had a crack through it. You know what, maybe we better test the radio at this point. This may have had a significant effect, I'm not aware of it. Always fun to test the radio, let's do that. Okay, so I have to short out the push button audio section, which is right up here. Not short out, actually. Actually, I'm making it continuous into the radio is what I'm doing. I shouldn't say short out. Let's connect. Okay, so that's connected, so we should get some sound out of the speaker. That's really all we need to do. So we plug them in. A little quick check for stupid things. Yeah, like that. There, see? This is why I do the quick check. I haven't even got the speaker plugged in. Okay, plug him in. Okay, let's okay, and ready on the, first of all, current limited power. There we go. Looks fine. Plate voltages not yet flowing. There they go. Full power. Here comes the sound. Let's plug in the antenna. We know short wave works, so let's check it. Let's see if there's any variation in what we know works. That's radio operation there. Oh my god. I'm not sure, but I think that's a foreign language shortwave station. I'm sure I heard the word Toronto coming in there. Yes. Okay. Now, back to the AM band. Let's get to the AM band. I'm really not very hopeful. That's some push buttons. And there, just goes silent with the AM side. Let's turn it up. And no variation again. I'm sure the oscillator is not oscillating. Now, what is the chance that I'm stupid here and I really need to have these connected? I'm pretty sure I don't need to have them in the circuit. That they're switched in as an alternative to the coils over here. Because I don't have this connected right now. And the radio is operating the same way it does when they are connected. So I think I can continue. continue stumbling around here. Oh my god. Okay, let's well, be careful now, the radio's on. I stick my fingers right in there without realizing it. Pretty quiet, eh? Didn't I find sounds here? What's happened? I thought we got sounds out of that last time my finger on the screwdriver shaft. Okay, seems to be working the same way it was. Now, you know what we got to do? Let's feed in. Let's get a signal going here for crying out loud. We'll play around with a AM band signal. Oh wait a minute, that's not going to help, is it? I gotta keep telling myself that because the oscillator is not oscillating. That's really where the problem is here. I keep losing focus. So I'm still pretty convinced the problem has to be down in this area. You know, a classic thing would be the wafer switch. It's not making contact. Let me wiggle it. But I've seen no indication that that's the problem here. Yeah. Yeah, there's no way that's the problem. The switch is good. What are the chances that it's just an alignment issue? No, that's not possible. There's no, like the oscillator is so far out of alignment it doesn't even oscillate. I can't imagine it. Because my imagination's pretty useless often, so. But that's not a road I want to go down. Defective tube? No, it's just not likely because it's oscillating in all the other bands. And a bum. It's a bum of a radio here. Time to ponder more. Okay, let's try this. Because it's my nature to fool around and try stuff, even when it might be a silly waste of time, I'm gonna reconnect these coils properly in the radio. Shut it off while I do this. And attempt to receive AM radio using the push button set, which I have not actually attempted. They sound like they're working to me, so I haven't fully investigated that. So let's just see for sure that those work. And maybe in the course of doing that, and we'll learn something that will point me in the right direction. So how should I flip this over this way? You know, the easiest thing I can do is just flip this right over like this. It's going to be facing the wrong way. Ow, ow, ow. Hot tube, hot tube. There we go. Now, you know, I don't like handling this thing an awful lot. Let's put our here it is. Put this guy on here. what are the chances that I have these 3 wires connected incorrectly, and either they're not connected or they're connected incorrectly, and in either case the AM radio will not work? I think the chances are very low. The radio did not work when I got it, and no reason to think anybody had reconnected those wires wrong. Boy, now I gotta try to remember which way to do it too. Okay. This goes like that into there. Put this up on top. And now it was blue at the back, black in the middle. This isn't going to work. Black in the middle. And this other yellow one up at the front. Pretty sure that's the way they go. Okay, we'll switch her on again. We'll have to set the band switch to push button. Here we are. See, that really, you know, that sounds what radios sound like in my house. Let's see if we can get some station coming in. Oh, antenna. Let me put the antenna on. Oh, it would be the loop antenna, wouldn't it? The loop antenna. Yeah. It's interesting it's receiving without the loop. Well, that's just noise, you know. And I think that certainly indicates the loop antenna does something. Let's tune. We're tuning this one here. You may notice I use a lot. Listen, I gotta talk about this. I use a lot of metal screwdrivers when I'm doing tuning, and you know, the mantra is never use these metal screwdrivers, and that's true sometimes, but lots of times you can use them. Lots of times. Here we go. Oh, you know what better way of doing this? Better way of doing this is, let's use my signal generator to find where this is tuned. That's a much better way of doing this. And it would have helped anyway if I plugged the antenna right in, but I hadn't yet. Plug the antenna into the signal generator. There we are. And we will set our signal generator to way up there now. Somewhere in the AM band. We'll go hunting. Let's see. So I'm tuning the signal generator, looking for a response in the radio. It should be quite dramatic when we get it. It should be any time now. It should be. It didn't show up. It did not show up. Come on, that's a little odd. Let's try this other push button up here. They don't make much difference, do they? I've always assumed that this is working because of the interference you can hear. I'm not so sure now. Okay, the signal generator is currently connected to the antenna input on the back of the radio. That should work fine. That should work fine. But maybe not. So let's clip. Put a. Oh, that was interesting. I just touched the antenna connection and the tonal quality of the noise changed. How come? Put this right on here. Doing nothing at all. Well, let's see if the oscillator is oscillating. I'm trying to turn that noise down and I can't. That's interesting too. It's about as quiet as I can get it. Okay, so we'll take a look and see if there is an oscillation coming here. You know what? I'm seeing nothing. Okay. Oh, whoa, 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 whoa. Don't jump. Nobody jump. Everybody stay right where you are. Let's change the band up. Oh, that's not the band switch. That would be AM. There it is. Okay, so you want to see that? I'm going to show you that. Okay, so I did manage to learn something here. I was making a bad assumption about what is working and what is not. Just okay, you should be able to see my scope there. And even if it's not clear, this is a sine wave from the local oscillator on a short wave band. I'm going to switch it now to first AM because that's where it goes. Okay, watch that. Okay, it disappeared. It's a straight line on my scope now, and now I've gone all the way down to the push buttons. Oh, you know what? Of course there's no oscillation seen there because it's no longer dependent on the VFO. I gotta find the oscillator up on these guys somewhere. Yeah. So let's look for it up here. Probably find it almost anywhere. Oh yeah, now I'm going to be wondering, okay, am I looking in the right spot? Is that why I'm not finding it, or is there none there? Because I'm not seeing it on the scope. I go out on these wires. You know what? There's nothing. There's no... The oscillator's still not working. Maybe it's making noise because of all this hardware. It's picking up more noise and delivering it to the front end of the radio more than if you're not using the push buttons and you're down using the VFO. So all that's happening when I switch to push button is it's becoming more sensitive to noise. That's why I'm hearing it. And the little bit of turning I did here, there was absolutely no change. I didn't do much, so it's not a really valid test, but everything's giving me an impression that there's just no oscillator when this thing's in AM mode. including these. So okay, so now that's interesting. I'm gonna have to go and study up again and see what it is that could affect either the VFO operation or the push button operation. Fun, fun.